Welcome back. Lesson number 3, what goes around? All right, today we're going to be talking about the sine and cosine functions. All right, this is kind of like a real introduction to trigonometric functions and things like that. If you did not take geometry, there might be a learning curve here on this one. If you did, hopefully you remember a couple of things. What I want you to remember is the following. This is called sine, all right? If I have sine of an angle, theta, remember that's our central angle. If I have sine of an angle, it's a relationship between the opposite side and the hypotenuse. If this is what we shorten for cosine, cosine is the relationship, the adjacent side over the hypotenuse. This is what I'm talking about here. So let's say I want to find angle A. So I want to find the sine of angle A. So the sine of angle A is opposite. So now check this out. Might be helpful to label it. So here's my 90-degree angle. Across from 90 is always my hypotenuse. Across from that is always hypotenuse. So there's two sides that touch this angle, the hypotenuse and the adjacent side. So this is the adjacent side. And then radical 3 over here is opposite. It does not touch. Now, if we were worried about angle B, that would be different, right? B1 would be opposite, but we're talking about A right now. So we want the opposite side. The opposite side is radical 3. And we want the hypotenuse, which is 2. So the sine of angle A is radical 3 over 2. It's a relationship, it's a ratio of the opposite side over the hypotenuse. Let's do the cosine. The cosine of theta, or A in this case, sorry, is the adjacent side. The adjacent side in this case is 1 over the opposite side, which is 2. All right, let's do one more. Let's do A here. So sine of A for this one is opposite 3 over hypotenuse 3 radical 2. Now, we do not like radicals in our denominator, so we have to do what's called rationalizing it. That means I have to multiply by the same radical. So I have 3 radical 2 over 3 radical 4. The square root of 4 is 2, so this is 3 radical 2 over 3 times 4. These cancel, so this would be radical 2 over 4. And that would be our sine, our opposite over our hypotenuse. Let's do cosine. Cosine of A is adjacent. Our adjacent side is 3. All right? Well, this is going to be the same thing. Look at this. 3 and 3. These are going to be the same thing. 3 over 3 radical 2. And we know now that that's going to be radical 2 over 4. All right? Very well done. All right, let's move on. So again, what we just talked about is that sine, the sine ratio, and sine is actually S-I-N-E. It's not sin. Please don't call me over and say sin. I'll know you didn't watch the video, and I'm going to call you out. All right? This is the sine ratio. It's the opposite side over the hypotenuse. This is the cosine ratio. Please don't call me over and say cos. You say cos, I know you won't have watched the video. All right? Simple as that. All right, now, we are going to use these two ratios today, sine and cosine, but specifically with very special right triangles. In geometry, you learn about a 30, 60, 90 triangle and a 45, 45, 90 triangle. Now, I don't like these X parts, so I'm going to label this always in a 30, 60, 90 triangle. Across from the hypotenuse is a length of 2. Always across from a 60 is a length of radical 3, and always across from 30 is a length of 1. That makes sense? All right. In a 45, 45, 90, we have two sides that are the same. They're length 1. And the third side, opposite the hypotenuse, is radical 2. Now, obviously this is easy to remember. 1, 1, radical 2. This one is easy to remember as well. It's as easy as 1, 2, radical 3. That's how I say it. But you always have to remember that the shortest side is across from the smallest angle. The largest angle is across from the largest side. Now, radical 3 people think is bigger than 2, but if you put in your calculator, radical 3 is actually between 1 and 2, so it's across from 60. It's the medium side. All right, so we have some angles here, and it talks about this being a unit circle. A unit circle means this hypotenuse is 1. Oh, man. All right. So what is the length of hypotenuse? We know that's 1 because it's a unit circle. That radius is the same anywhere we go on the unit circle. All right. And question number 2 says wants to label the side lengths. Now, we're going to do this a certain way this time, and it totally works. All right. And then we're going to do it another way the second time. And I think that's a better way. But I like having 2 ways for you guys. All right, so I'm going to label this. I'm going to use this as my reference here, right? Now, I know that this was my hypotenuse, and it needs to be 1. Well, how do I get this 2 to equal 1? I have to divide it by 2. So I have to divide all these sides by 2. So 2 divided by 2 is 1. Now this side length here is going to be 1/2. Now this side length here is going to be radical 3 over 2, right? Now if I do this one, I got to divide by radical 2. I got to divide everything by radical 2. Now again, we don't like radicals in our denominator, so I'm going to rationalize it. So that's radical 2 over radical 4. And the square root of 4 is 2. So now we know that this is radical 2 over 2. This has to be the same, radical 2 over 2. All right, this is the same triangle here, but we have a couple of different sides, right? Across from 60, let's look. Across from 60 is radical 3 over 2. And across from 30 is 1/2. So this would be 30, so this would be 1/2. So these are side lengths of a triangle when we are on the unit circle. And that's very important, all right? In fact, it's so important that we're going to skip to page 787, okay? All right, page 787. All right, we're going to label these points, okay? And we're going to do a couple things. We're going to find both of these things here. So I'm going to draw this triangle right here. All right, this is a 30-degree triangle. So now, here's the way I want to do it. All right, best way I think possible. I know every time across from 30 is 1. I know every time across 60 is radical 3. And I know every time across 90 is 2. All right? So let's say I want to find cosine of this angle. Cosine being what? Adjacent, right? Cosine being adjacent. Now notice, if we had 2 things here, adjacent is right here. That's going left and right, isn't it? So let's call that an x value. All right, so what would be the cosine here? Adjacent, radical 3 over hypotenuse 2. All right? Now we're going to do our sine one. So that was cosine of 30 degrees because we had 30. Now let's do our sine of 30 degrees. Our sine is opposite 1 over hypotenuse 2. And notice how this is my sine. This is the side that reflects my sine, and that's going up and down, much like a y value. And it's very important, actually, that you understand that this is an x value, and this is a y value. Now let's look at some symmetry of this triangle. We know for instance, we know over here, we know that this is a 30-degree angle here, right? We know it's 150, but we know this reference angle here between the x-axis and our terminal angle is 30 degrees. Notice something, all right? That's 1, that's radical 3, that's 2. The only difference on this is what? This radical 3 is going to the left. So if this was an x-coordinate, this would be negative 3, right? So let's find the cosine. And I'm always putting the cosine in the x because it's adjacent, right? So adjacent, negative radical 3 this time, and hypotenuse 2. Let's take a look at our sine. Our sine is a y value, so that would be up 1 over 2. Still going up, all right? So the cosine of 150, or the cosine of 5 pi over 6 radians, is negative radical 3 over 2. The sine of 150, or the sine of 5 pi over 6 radians, is 1/2. Let's look at some more symmetry here. Let's see if we can't figure this out without doing the calculation. So we know this is 30. All right, so far, cosine has been the same every time. Radical 3 over 2, we just changed some negatives. So Let's change some negatives. This is the third quadrant. That means I'm going left. So that's negative radical 3 over 2. My cosine is negative because it's an x value, and x values going left are negative. My sine value this time is going down, right? So my sine is going to be the same exact thing, 1/2, but in this case it's going to be negative 1/2 because it's going down, right? Sine values are y values, cosine values are x values. All right, last one over here. Let's find look again, 30-degree angle. So this is 330. So all the way over here, cosine of 330 or cosine of 11 pi over 6. We know this is going to be the same setup here. I'm going to the right, so my x value, my cosine value is radical 3 over 2. My y value, my sine value is going down. So that would be negative 1/2. All right? So everywhere we have a reference angle of 30 degrees, I know that I'm going to use some variation of this, radical 3 over 2 for cosine and 1/2 for sine. It just depends on if I'm going left, right, up, or down, right? And in these quadrants, it talks about, now, I want you to switch this because I want you to understand that cosine is an x value and sine is a y value. So in the first quadrant, my cosine values go to the right, so those are positive numbers. My sine values go up, so those are positive values. In quadrant 2, again, switch these. I want you to understand it's x, y. I have no idea why the book would do this. So to the left, my cosine values should be negative. Up, my sine values should be positive because I go up. Down here, let's take a look. I'm going left, so my cosine value should be negative. And I'm going down, so my sine value should be negative. Over here, my cosine value, I'm going to the right, so it should be positive, and my sine values are going down, so it should be negative. All right? All right, now we're going to do pi over 4 radians, which is 45 degrees. All right, we know that when we have a 45, 45, 90-degree triangle, the side opposite is 1, the side adjacent is 1, and the hypotenuse is radical 2. So let's do cosine my x value first. That is going to be 1 over radical 2. Now, we don't like radical 2's in the denominator. I'll come over here again. 1 over radical 2. I'm going to rationalize it. That gives me radical 2 over radical 2 times radical 2 is 2. So this is really going to be radical 2 over 2. And it's to the right, so it's positive. It's an x value. Let's do sine. Sine is opposite 1 over radical 2. That's exactly the same. So now that is radical 2 over 2. Radical 2 over 2. All right, so 45 or pi over 4, they're always going to have a relationship of radical 2 over 2. Now let's quickly use our symmetry and label this. I know this is going to be some form of radical 2 over 2 because this right here is a 45-degree reference angle. 180 minus 45 gives me 135. The one difference is I'm going to the left, so my cosine value has to be negative. I still go up, so my sine value is positive. Let's go here. 180 plus 45 degrees. That's going to be 5 pi over 4, or 225. Again, I know it's going to be some value of radical 2 over 2 for both values. All right, I went left, so my cosine, my x is negative. My sine, my y value is also negative. All right, and last but not least, let's go to 315. 315 is 360 minus 45. I'm going to the right, so it's positive radical 2 over 2, and I'm going down, so it's negative radical 2 over 2. All right, I want you to try to find pi over 3 and use the symmetry to find all the other sides. All right, so pause the video and do that now. All right, so I went to the first quadrant. I had this is my 60-degree angle. Across from 60 is radical 3. Across from 30 is 1. So here I did cosine. My x value is adjacent 1 over hypotenuse 2. My sine is opposite radical 3 over hypotenuse 2. So now I know all these angles are going to be 1/2 and radical 3 over 2. So this is going to the left, so my cosine is negative, and my sine is positive in quadrant 2. In quadrant 3, my cosine is negative, my sine is also negative because I'm going left and down, so cosine of negative 1/2, sine is negative radical 3 over 2. Quadrant 4, I'm going to the right, so my x, my cosine is 1/2, my y, my sine is negative because it goes down, negative radical 3 over 2. All right, let's take a look, see what these graphs look like. So we have this graph. Let's plot it. See what happens. All right. So first thing we got here, we're going to do one full rotation. Now I labeled these. You may want to pause the video right now and jot this down. I'll go over how I got these with you. These are just from that unit circle, but I'll go over it. I went by every other line was 0.25. So take a second, pause the video, jot that down. All right. Now that we're back, we're going to do one full rotation. So at 0, remember my y value is what I'm looking for here because I'm doing, this is my sine theta graph. All I care about is sine theta. So what is my sine when I'm right here? Well, that goes up, doesn't go up at all. So that was 0. So I'm going to plot at 0, I am 0. All right. Now you'll notice that each one of these is pi over 4 in between here. So that's what I did. Pi over 4 is a 45-degree angle. That was radical 2 over 2. That's about the same as 0.707. So I'm going to go over pi over 4 and up about 0.707. It's not going to be perfect, people, but it's somewhere in there. Sine of 1. Sine of 1 is right here. That's like 0, 1. That's my coordinate. 0 over, up 1. My sine value is the y coordinate, so I'm at 1. So at pi over 2, I'm at 1. At sine of 3 pi over 4, which is the same as 135, right? I'm at radical 2 over 2, which is my 0.707. When I'm back at sine of 0, which is right here, I have not gone up at all, so my sine of pi is 0. So I'm back here. And again, you can get these right off your unit circle, all right, that you just made. Now I'm here at 5 pi over 4. That's negative 0.7 over 7. So that's going to be somewhere in here. At sine of 3/2 pi, I'm at negative 1 directly down. So that would be here. All right. Over here, I'm at negative radical 2 over 2, so at 7 pi over 4, I'm here. And then at 2 pi, I'm back to 0, because this, remember, is 0 or 2 pi. So now this sine graph looks a little bit like this. Oh, just like that. All right, so that's what the beginning of a sine graph looks like. Now, you'll see in a second that this is just going to repeat over and over and over again, all right? All right, I want you to pause the video. I want you to put all the values of cosine here and then make the graph and see what it looks like. All right, go ahead and pause the video. All right, so I started at 1. I worked my way down when I was at pi over 2. Pi over 2 is right here. I'm at 0. At pi, I'm at negative 1. Working my way back up here. All right, it looks very similar to the other one when you see it extended. So let's go extend it. All right. So on page 782, we're going to extend this graph. Couple of things I want to talk about first before I get there. Look at our sine graph. We did from 0 all the way down to 2 pi. But what if I did from 2 pi to 4 pi? It'd be the exact same thing. And from 4 pi to 6 pi and from 6 pi to 8 pi, it'd be the same thing. It's very repetitive. It's cyclical. All right? So let's graph this sine function. That means every 2 pi units are the same. So if I start at 0, 2 pi units away is going to be at 0 in either direction. Boom. 4 pi units away, 0. 2 more pi, 0. 8 pi, which is 2 more pi units away, 0. Let's go to this one, this 0 here. That's at 1 pi. Well, 2 pi units away, it's going to be there. 2 more pi units away. 2 more pi units at 7 pi. At 9 pi, it would be back to 0, right? But I think we run out of space. So we're not at 9 pi. Going this way. 2 pi units away from there, add 0. Now look what happens between these two here. Between these two, it's at my highest point. So 2 pi units away from here would be between these two. That's my highest point. 2 pi units away from here, again, here, highest point. 2 pi units away, highest point. 2 pi units away, highest point. All right? 2 pi units away from here, my highest point. Let's look here. The next, between my next two would be my lowest point. So between these would be 2 pi units from here. That's my lowest point. That's my lowest point. That's my lowest point. That's my lowest point. So a couple things. Let's graph that. Now, I apologize. These should be rounded. You should have a perfect graph. However, me doing this on this board is really, I've discovered, just terrible. But it's the same. It's cyclical. Every 2 pi units is exactly the same. Okay? So I want you to take that, and I want you to do the cosine. So do every 2 pi units, just with the cosine. Same thing. Go. All right, so let's take a look. I'm at 1. 2 pi units later, I'm at 1. 2 pi units later, I'm at 1. 2 pi units later, 2 pi units later, 2 pi units later. I'm at my negative 1. 2 pi units later, 2 pi units later, 2 pi units later, 2 pi... Very cyclical. Between my two lows, halfway between my two lows, I'm at my high. Between my high and my low, halfway between my high and low, I'm at my 0. It's very cyclical. All right. So on page 785, I want you to use the graphs we just made and complete this table at the bottom. All right. The sine and the cosine, finding as much of that as you can. Okay. And then on page 789 to 790, I want you to do numbers 1 through 6. All right. Good luck. Make sure you ask lots of questions.